Welcome back. Today is our last lesson in our review of probability. So today we're going to be discussing theoretical probability and experimental probability. First, let's go over a few vocabulary terms. An experiment is an activity involving chance. What experiment do you see below? And this is the experiment I'm referring to. So the activity involving chance would be rolling a dice. Next, an outcome is the result of an experiment. For the experiment below, what is one of the possible outcomes? So if you said rolling a 5 or rolling a 4 or any of the numbers that would be on the dice, that would be correct. So you can choose whatever number you prefer. I'm going to put rolling a 3. So that's one of the possible things that could happen when we roll the dice. The sample space is the list of all of the possible outcomes. So for this experiment here, what would be the sample space? Well, it would be 1, 2, 3, 4, 5, 6. Why would we not include 7? If you knew that 7's not on the die, that's exactly correct. And then the last vocabulary word is an event is a set of one or more outcomes in an experiment. It is what we're looking to happen. And so we're going to see this in the example below. So now let's go to theoretical probability. Theoretical probability is the chance or likelihood an event will occur. In theory, it is what we predict will happen. And we write it in this special way. P for probability and whatever we're looking to happen. For instance, landing on a 2. So we would write it the number of favorable outcomes, how many of whatever event is possible to land on, and then the total number of outcomes. So let's go ahead and try this. Let's look at problem number 1. If you were to roll the dice one time, what is the probability it will land on a 3? So let's start by writing this correctly. We will put P for probability, and we want to put 3. We're talking about landing on a 3. So we'd have to go back and ask ourselves how many 3s are on this die. So there is 1 3 on the die. And then we'd ask ourselves, what are the total number of outcomes? Well, the die has 6 sides, so it would be 1/6. And we could, of course, convert this to decimal or to percent, but for right now, we're just going to leave it in fraction form. We do usually choose to simplify it if possible. So the next question says, if you were to roll the dice one time, what is the probability it would not land on 6? So once again, we want to write probability using this notation, which means the way we write it, P for probability and not a 6. So we don't want to land on 6. So now I have to think of how many possible outcomes, or favorable outcomes would not be on 6. Well, there's just 1 6 on the die, and so there are 5 other numbers that are not 6. So that would be 1, 2, 3, 4, and 5. Those are not 6. So there's 5 different numbers that are not 6. And out of all the total number of outcomes, that would be 6. So I'm going to let you look at 3 and see if you can answer number 3. It says, if you were to roll a dice one time, what is the probability of landing on an even number? And those being 2, 4, 6, and 8. So pause it and write this, please. So the even numbers are 2, 4, and 6 on the die. Our event that we're looking at is even numbers. So we'd write probability of landing on an even number. And there's 3 even numbers out of 6 possible outcomes, and we'd reduce it to 1/2. So now let's go on to experimental probability. All right, so experimental probability. That's probability based on an experiment, and it's written as P and the event, meaning probability of the event, whatever we're looking for, and the number of favorable outcomes. And I should very definitely clarify this, so please write this in on your notes, that this means in the experiment. So what actually happened when our event, or how many times do we see our favorable outcome in the actual experiment? And that's over, a very important difference from theoretical, the total number of trials. How many times was this experiment performed? For instance, if it was rolling the dice, how many times did they roll the dice? If they spun a spinner, how many times did they spin the spinner? So trials, when we say that, are the number of times an experiment is performed. So now let's go on to question 4. Tessa rolled a number cube 10 times. The number cube landed on the number 2 6 times. Write the experimental probability of landing on a 2 based on the experiment. So let's highlight several important things here. She rolled the dice 10 times, so that's the number of trials. It landed on the number 2 6 times, so that's the favorable outcomes. And what we're doing is our event is landing on 2. So let's write this as probability. So we're going to start by writing probability, and we're going to put that we're trying to land on 2, so I should write the word land on 2. And it turned out that she landed on 2 6 times in her experiment, and she performed her experiment, or she did the experiment 10 times. So once again, we could reduce that, both of these numbers. We could divide by 2, and we would get 3 out of 5 times. So let's try another one. Let's read through this. Malik flipped a quarter 20 times. The quarter landed on tails 12 times. Write the experimental probability of landing on tails based on this experiment. So let's highlight some information. Malik flipped the quarter 20 times. And so that's the number of trials. He landed on tails 12 times. Those are the favorable outcomes. And we're supposed to write the experimental probability of landing on tails. So let's start by writing the notation properly. So we're going to start with the probability of landing on tails. And then we look at this. He landed on tails 12 times, and he did 20 trials. So again, if we reduce this, this is going to be 3/5, because we can divide by 4 and divide by 4 both. Finally, let's see how we can extend this and use this to help make predictions. Kathy is an inspector for a t-shirt company. After inspecting a typical shipment of 100 t-shirts, she notes that 3 of them have defects. At this rate, if Kathy has to inspect a shipment of 500 t-shirts, about how many of them would you expect to have defects? And you're going to see something familiar that we've used. We get to use a good old-fashioned proportion to help solve this. But before we do, let's go back and let's look at what the information is they gave us. So it said that she looked at a typical shipment of 100 t-shirts. She noticed that 3 of them had defects. And they're asking us, if she inspected 500 t-shirts, about how many could we expect to have defects. Now, this doesn't mean that out of every 100 t-shirts, 3 will always have defects. It's just that this will help us make a prediction. So if we look at this, we're looking for the probability of how many t-shirts had defects. And if we start with the 3 had defects out of 100 that she inspected, but she's not going to inspect all 500 t-shirts. So if we wanted to predict how many would have defects, well, we don't know that. We're trying to figure that one out. However, we are talking about a total of 500 t-shirts. So we could write a proportion. This is one of the ways we could solve this. And again, we cross multiply and get 100x. Got the x, and then 3 times 500 would be 1500. And then we're going to divide by 100 on both sides, and that is x equals 15. So what did we find out again? Well, we're looking for how many t-shirts could we expect to have defects. So we would expect about 15 t-shirts to have defects. Now again, we can't say with certainty. That's what probability is all about. It's probably going to happen. All right, so final problem. Let's look this over. All right, and we have a typo in this one, so we'll go over that when we get to it. Evan conducted a survey of favorite snack foods. He recorded his results in the following table. Based on the results of Evan's survey, about how many people in a random sample of 250 would be expected to prefer cheese curls. So once again, we're going to go back and figure out the information that we know. He conducted a survey, okay, and we can see this here. The only bit of information that they gave us in this paragraph is that the random sample that they want us to think about predicting for is 250, and we're looking for cheese curls. So we're going to start at the table. Now, sometimes to figure this out, it looks like that cheese curls, 9 people liked cheese curls. So we at least have something to start with. So the probability of people choosing cheese curls based on the experiment, 9 people chose cheese curls, but what we don't know is how many people he surveyed. So we're going to have to add all of these numbers up. 20 plus 3 plus 18 plus 9 would give us 50. The total is 50. So that's the number of trials or number of people that he asked. And now we're trying to figure out about how many people would choose cheese curls if he asked 250. So I'm sure that Evan doesn't want to ask 250, so that's why this comes in handy if we can make a prediction based on perhaps a smaller trial or a smaller experiment. So would you please pause this video now and work this out on your own, and then check back when you're done to see if you agree with the answer. And that would be about 45 people would choose cheese curls out of 250. Thanks for listening.